following instructional video from a particular installation represents one of the many applications of the FATRAFOL-S waterproofing system in practice. The company FATRA-AS is a manufacturer and guarantor of the waterproofing system FATRAFOL-S, recommends entrusting the application to a professional company which is trained in the system and with proven experience within this field. In addition to requirements related to work safety, it is necessary to take into account that the construction site and worksite area is defined before the initiation of the project. Examine the construction site for full protection system, job site access, possibilities to handle and store material, connection to energy supplies with consumption measuring, eventual operation restrictions with respect to fire protection and preservation of the environment. Protocol or record in the construction project logbook is made on the handover and takeover of the site or workplace. This record should also include handover of the roof-based structure. By signing these documents, the contractor is authorised to use the construction site and workplace for execution of his contractual obligations. The delivery of waterproofing materials is provided by conventional means of transportation to the construction site using suitable handling machines. Upon material delivery to the job site, inspect the quantity and quality according to the delivery note. Product data is indicated in the identification label of the package unit. Should the material fail to comply with the required specification, it is necessary to claim it immediately with the supplier. On the construction site, waterproofing materials are stored in places predetermined for that purpose. It is recommended to store all supplementary and auxiliary materials in a lockable container. Horizontal transport on the roof under construction is usually done manually or by small mechanisation. It is appropriate to establish a transport corridor on the trapezoidal sheet base and the roof shell under construction, for example by laying wood particle boards on a separation textile. Prior to initiation of a vapour barrier installation, we remove dirt and standing water from the trapezoidal sheets. All prevention measures are necessary in the case that the worker operates closer than 1.5 metres from the roof edge. It is necessary to close the wave of trapezoidal sheets with suitable steel sheet profile at the parapet base. The membrane is rolled out parallel to the orientation of sheet corrugations so that the joints are on the crest of the wave. Minimal suggested overlap of the sheets is 100 mm. Joints are adhered together with butyl rubber tape and subsequently rolled over with welding roller. Cross joints must be supported with a firm underlay. The vapour barrier is connected to roof boundaries and penetrations also by butyl rubber tape. The minimum height of the vertical extraction is usually defined by the thickness of the thermal insulation. The reliability of the vapour barrier, its integrity and airtight connection to construction details is essential. Installation of the thermal insulation can start after base or vapour barrier takeover is recorded in writing. Thermal insulation boards are laid on the trapezoidal sheets with their longer side perpendicular to the corrugation. Damaged, deformed or wet boards must not be installed into the roof shell. A combination of mineral wool and polystyrene thermal insulation used in this application was subject to the fire resistance of the structure. Insulation boards can be formatted by special knives, saws or by other methods recommended by the manufacturer. Gaps in joints must be filled with sealing compound, for example polyurethane foam. Thermal insulation boards must be anchored during installation to their underlayer by at least 2 fasteners per square metre unless their fastening is provided during anchoring of the waterproofing cover. The inspection of the installed layer and the approval to install another layer must be documented in the building or installation logbook. The membranes based on plasticized PVC must be separated from polystyrene boards due to mutual negative interaction. Glass fibre mat, which also increases fire resistance of the roof cover, is the suitable material. Strips can be shaped using a regular insulation knife or scissors. Glass fibre mat is laid freely with 50mm overlaps and taped by single-sided tape. Remove the membrane roll from its protective cover. Remove and save the identification label and roll the membrane out at the area of installation. On bases from trapezoidal sheets, membrane sheets are always orientated perpendicularly to corrugation, diagonally in exceptional cases only. Let the unrolled membrane rest freely for several minutes to eliminate tension generated in the production process. Extend the resting time adequately in lower temperatures. Before starting the mechanical fastening, check the straightness of the sheet, corrugation on edges and surface, and eventual visible defects. Membrane sheets with such defects must not be installed. Individual sheets are shaped in compliance with the approved anchoring plan and roof geometry. Dimensions are adjusted using an insulation knife or scissors. Never tear the membrane by hand. Adjust the position of the unrolled membrane with respect to the required overlaps. Suggested longitudinal overlap with mechanically fastened sheets is usually 110mm. An identification print 120mm from the sheet edge can be used to set the membrane to the correct position. For cross overlaps without fastening, a 50mm overlap is sufficient. Moving adjacent strips in a longitudinal direction prevents incurrence across butt joints. For better weld geometry, it is suitable to round off strip corners. Fasteners must be placed in the upper corrugation of the trapezoidal sheets under layer. The span of anchoring lines in between fasteners is usually defined by the anchoring plan. Plastic tubes or metal plates must be placed to maintain the distance of 10mm between the edge of the plate and the anchored strip. If the fastener is placed closer to the sheet edge, its bearing capacity is reduced. Using anchoring machines with adjustable depth retainer and torque adjustment provides optimum static efficiency of the fasteners. The anchoring machine cannot be used for any reason. We use manual power tools. The suggested depth of the screw concealed in the trapezoidal sheet is 20mm. Connecting membrane sheets by hot air welding is preferred with respect to joint quality, working comfort and other requirements. Suggested welding temperature for PVC-P base membrane is 500 degrees to 600 degrees Celsius, and for FBO base membranes 480 to 530 degrees Celsius. Correct temperature needs to be verified by testing the weld. Welding equipment is classified as manual welding devices and automatic welding machines. The welding process starts immediately after the verification of welding equipment setup on anchored foil strips. On manual welding devices, only temperature can be set. Down pressure and speed depend on the welder's experience. The welding tip is directed between both welded surfaces. These must be clean, free of dust, mineral wool fibres, water, snow or ice. The down pressure is achieved by the roller, which moves diagonally to the weld axis. For T-joints, it is necessary to increase down pressure by roller edge. Dirt captured on the nozzle must be removed continuously by a steel brush. for automatic welding machines set up the temperature, air volume, travel speed and down pressure. These parameters are verified by the test weld and recorded in the building log. When the automatic welding machine is used, pay careful attention to maintaining the correct weld geometry. The waterproofing membrane is ended around the roof perimeter by flashings made of plastic coated sheet metal profiles FATRAFOL. These components stabilise the membrane against internal forces and dimensional changes. In the parapet inner corner, the waterproofing membrane is brought to a vertical position approximately 50mm above the roof level and trimmed. Install an internal corner profile from plastic coated sheet metal and fasten it along with the membrane to the underlayer. Profiles are fixed to the underlayer by fasteners placed 250mm apart with an expansion gap of 2 to 3mm between adjacent pieces. This expansion gap is not overlapped by patch from homogeneous membrane as in drip moulds and gravel stop applications. The parapet is ended by a cladding system component. An external corner profile is installed on the upper edge, enabling ending of the membrane on the upper inner corner of the parapet. This will protect the membrane against cutting in case of sharp edges of the cladding panel. Fix the upper edge of the vertical membrane strip to the plastic coated external corner placed on top of the parapet by temporary point. Hot air weld first and then weld the lower edge to the plastic coated inner corner profile placed in the inner lower part of the parapet with brass pressure roller. Release gradually the point weld fixation, straighten the membrane and weld it back to the plastic coated external corner profile. Cut off membrane excess parallel to the external profile on top of the parapet. Weld the membrane fully to the inner corner profile first and then to the horizontal surface of the waterproofing membrane using a structural weld with minimum width of 30mm. When finishing the base of skylights and fire dampers, proceed identically as for regular square or rectangular penetrations in the roof shell. Transferring the waterproofing cover to vertical surfaces is the same as parapet finishing. Bring the membrane up at the base of the skylight to approximately 50mm above the horizontal surface and fasten the plastic coated inner corner profile using prescribed fasteners. To transfer the waterproofing cover to the vertical surface, use a strip of FATRAFOL 810 membrane. Fix the upper edge of the membrane strip to the previously installed plastic coated profile by point hot air weld. Straighten the membrane strip and weld it to the inner corner profile. Cut off the membrane overlap along a flexible steel straight edge. To connect the membrane strip to other sides of the skylight, leave enough overlap at the sides. The point hot air weld of the upper strip edge enables ventral corrugation corrections. After the position is corrected, weld the upper strip edge to the end profile. Weld membrane side overlap to the adjacent strip. And overlaps fully to the main membrane surface. To seal external corners, use 3D shaped pieces made of 2mm homogeneous membrane FATRAFOL 804. Finish the entire perimeter of the skylight using the same method. Weld correctness is checked by a seam probe. It is recommended to apply sealant Z01 on all seams. Internal drainage components are fitted with a slight recess into the thermal insulation. It is recommended to use rigid rainwater outlets with an integrated sleeve. In case of negative pressure drainage applications, rainwater outlets with fixed and loose flanges are used. After setting the rainwater outlet into its position, it is necessary to use additional mechanical fixation to the underlayer. Safety overflow outlets are installed to drain rainwater during temporary non-functionality of the drainage system. Overflows might be created as narrow slots in the parapet in the access of the roof valley, with a difference in elevation of the overflow edge 50 to 70mm. At the entry point to the roof, waterproofing membrane and thermal insulation are exposed to increase point load. Therefore, it is recommended to add wood particle board to spread the load. When installed on the finished roof cover, the whole board must be wrapped in unwoven fabric and covered with a membrane FATRAFOL 814 with non-slip pattern, or with membrane FATRAFOL 810. Membrane sheet is welded around its perimeter to the main roof covering. Tightness tests of the waterproofing cover welds demonstrate water tightness of the finished work or its integrated part. Test results are usually reported in a protocol or recording in the building logbook. The most conventional weld tightness test is the test using a seam probe along with a visual check of the waterproofing cover compactness performed by the contractor. The probe tip is directed in the weld seam edge with slight pressure. Loose areas are detected when the probe tip penetrates into the seam. The penetration point is marked and fixed with a patch. The test consists of checking randomly selected wrist points of the waterproofing cover, in particular T-joints, external and internal corners, repaired welds or welds with non-standard geometry. The equipment needed for the test is a vacuum pump, connection hose, transparent vacuum plungers with manometer, and detection liquid, usually water with added detergent. The liquid is applied on the tested point and covered with the plunger. The vacuum pump sucks the air from the plunger, depression is generated at the tested point, and if a defect is present in the weld, bubbles form on the membrane surface. Any loose areas are repaired with a patch. There are also other non-destructive testing methods based on various physical principles. They include in particular the flood test, spark test, thermovision camera test, or impedance defectoscopy. Treating welds with a sealing compound is recommended in the FATRAFOL-S system for some types of welds and for determined configurations. It applies in general that welds with spatial details, T-joints and roof penetrations are treated with a sealing compound of the same colour as the membrane. Weld treatment is also suggested for configurations of the roof shell where the waterproofing layer is covered by other layers. Safety sealing compound must be shaken thoroughly and diluted if needed before application. Do not apply sealing compound when it is raining or on a wet base. Safety sealing compound has a significant influence on the overall visual impression. However, it does not substitute hot air weld joints and has no sealing function. After completing all activities on the roof shell, material residues are removed and final cleaning is performed. To remove ordinary dirt and marks caused by electrical extension cords, washing with water with added detergent is sufficient. In case of membrane contamination by bitumen or black rubber, petrol may be used. Rinse clean surfaces with water. Handover and acceptance of works is preceded by an inspection of the work that must prove its completeness, compliance with specific requirements and specifications, and the ability to use it in the agreed or usual manner. Actual defects with terms for their correction are stated in the handover and acceptance protocol. Suggested enclosure to the handover documentation also includes the operating regulations of the roof, defining among others inspection terms and renewals or replacements of individual structural sections of the roof shell. The roofing waterproofing system FATRAFOL-S offers a fast, high quality, environmentally friendly and affordable solution, not only for restoration of the roof shell, but also for newly constructed buildings. The membrane, with additional and auxiliary materials, might be used for almost any structural design. The versatility of the FATRAFOL-S system is based on its wide variability, degree of development of technical solutions, and the valuation of long-term experience gained in more than 40 years of continuous development.